Okay, welcome everyone. It's a pleasure to present the next module for migration to Setonix. In this case, it's Migration Module 6. And we're going to talk about how to use your data in the new system. So it is not about migrating your data. It is more about how to change your workflows and how to use the new data facilities in Setonix. For the new use of the new computer. Okay. Next slide. Okay, these are the learning outcomes from this module. Basically, understanding the importance of managing your data for your the entire life cycle of your project. The core of the module is how to incorporate Acacia into your workflows. A little bit of what data needs to be migrated from the old systems into Acacia, how to use the clients, not in great depth, but it's a good introduction on how to use the clients of Acacia, how to manage your data and best practices considerations. So first section is going to be about a general view of the workflows and how data can be managed along the way. So this is a big picture view of a, if I can say, a typical workflow, and we are going to focus on the typical data management within the workflow. This is a long workflow, but a very, if I can say, very typical for our users. So I will show bit by bit. So in the first part, we consider how to transfer data into Pawsey, but as I said, we are talking about the new way of dealing with the new infrastructure. So in this case, we consider that the typical movement of data into Pawsey should be towards Acacia. This is different from the old systems where you probably move data directly into Scratch or into Group. In this case, we are recommending to move your data directly into Acacia first. So data could come from a collection from an experiment or from other institutions, basically any data that is out of Pawsey. The next part is how to use your data in a supercomputing calculation or a supercomputing job. So once the data has been stored in Acacia, you cannot use it directly in Acacia because Acacia is an object storage designed just to store data, but to consider information that is there immutable. So what you need, and also it's not as fast as the Scratch file system. So to have a performant job that needs to read and write information in a supercomputing job, we need a fast file system to do those input-output operations. So the first step for this is you have your data in Acacia, you need to stage it into Scratch. And then once it is in Scratch, you have a process or a supercomputing job that uses that. So Setonix is marked here as a step that is going to process the data. Typically can be an input data, and then the results or data generated by the supercomputing job is going to be written back into Scratch. And then possibly once the job is finished, it can be moved into Acacia again. Typically, supercomputing jobs are longer than the whole time we have for our jobs in Setonix. So if they go beyond the 24 hours limit, you probably need to use those results back again to following up calculation. So that's what it is indicated in this loop. So it basically saves some results that we call them checkpoints and reuse them to restart another job and another job until the research outcomes are satisfied. While you are reusing these checkpoints, you can keep storing into Acacia whatever is needed. And yeah, the final, if we can say the final results, will end up in Acacia for further analysis later. Just remember, we don't have group anymore, and Scratch has a limited time for the files to be there. So there is a purge policy of 30 days. So that's why we need to move our generated results out of Scratch, in this case, into Acacia. And also, well, remember to clean any information that is not needed by you anymore in Scratch, to clean it, because this file system is a shared file system that needs to be properly used for optimal performance. So this is a little bit more about the same, but in this case, we are considering another possibility that once you have stored some information into Acacia, you may need it again for follow-ups. So it's basically something like reusing those checkpoints once they are not available in Scratch. So you need to stage them again and then use them in your supercomputing jobs again. And then you can have this shorter loop of the results again. It is basically the same process here, with the additional consideration that once you have stored data in Acacia, you can stage it again and follow the process for your calculations again. So now in this last part of the workflow, we are considering that once you have data stored in Acacia and you need to do some other kind of post-processing. For example, post-process it to visualize the data and generate images and videos. Now you can stage your results not into the Scratch of Setonix, but into the Scratch file system of the visualization cluster. In this case, we count at this stage for first stage of Setonix, we're going to be using Topaz and the Nebula Windows-based clusters for visualization. So you can stage your results or your data into the Scratch file systems of these clusters, process it, and if needed, just not to complicate the schematics, we are saying to your results of your process can be stored back into Acacia, but you can, at this point, transfer it to your own institutional computer via other ways. It doesn't need to be stored in Acacia. So basically, you store in Acacia what you will be needing to use for continuing your research. And that's it. But you can move your stuff out of Pawsey at any time. And well, again, the idea was not to complicate the schematics, etc. But this is the final stage that I was talking about. So once you don't need your data in Pawsey anymore to do some processing, you should be moving it out of Pawsey and storing it in your own institution for your own purposes. It is important to remember that we do not provide backups of the data. So if you need a real backup of your data, let's say an historical backup that can catch any changes along the time, etc. We don't provide that. So you need to be doing your own backups and transferring this into your own institution if you need that kind of backups. So Acacia has backup, but more backups in the sense of failure. So it is a system that is prepared to resist some kind of failure and has some kind of duplication of information, etc. But it is not what we will think of a backup of your historical data transformation. Okay, so again, the whole picture of the workflow. So it is a good time to think about your own workflow. So basically, how many intermediate store operations into Acacia you may need. If this staging of data is just a few megabytes, or you will need to be staging large amount of data, so you need to prepare scripts for doing that, etc. Basically, think about how much data you will be needing for your process, and how many times you will be needing to move it in and out Acacia and into the supercomputing file systems. So for the first and last part, which is transferring data into Pawsey or out of Pawsey, as I mentioned, this route of transfer first into Acacia and then into the file systems of the supercomputers to be used, or transfer real results from the supercomputers into Acacia first and then to your own institution or your own computer, is one of the routes that is now available. We are recommending this because, well, Acacia is a place where your data can be stored for the duration of your project. And to do those transfers from the world or towards the computer or vice versa, mainly to interact with Acacia, which is, as I said, is an object storage. You will need a S3 compatible client that can talk to Acacia, which is object storage that talks the S3 protocol. So these S3 compatible clients are the tools to be used for those transfers. In this case, we are at Pawsey using these 3 clients. There are many available clients for you, but we recommend you to start with this, and we are considering to support the use of MC, the minio client, which is a client that has the peculiarity of being more straightforward to use. These clients are already available in our clusters, and if you need to use them from your own computer or your own institutional computer, you will need to install them over there. More about how to install them and configure them is in the Acacia user guide. But don't forget, I wanted to also have this slide just to remind that there's still the old way of dealing with transfers in and out of Pawsey. So you can perform transfers in and out of Scratch, the Scratch file system. And well, obviously also software and home, but basically the idea is that you can still perform file transfers via the tools with SSH protocols like SCP or FTP or rsync. To do that, you should be using the data mover nodes. So the DNS name for the nodes that will be assigned to perform all the data moving is not Setonix the name. You need to use datamover.pawsey.org.au as the address to connect into that into those nodes for performing the transfers. This is, you already know about this. This was already mentioned in the previous modules. Okay, so a little bit more about Acacia, because I mentioned that you need to use this S3 S3 compatible clients. So to start with, Acacia is a high performance, large volume Ceph object storage with an S3 interface. So basically, if you are familiar with the object storage of Amazon, the Amazon S3, well, basically the behavior of Acacia is very, very similar to Amazon S3. The total capacity of Acacia is 60 petabytes. Initially, every supercomputing project will have an allocation of 1 terabyte. And that is where users can put their data. You need to consider that the data is shared among all members of the project if you are using that allocation to transfer your data and to manage your data. There is also an individual allocation for each user where data there is not shared with anyone else. So basically, what I mean about sharing is that every other member of your project can read, can write into the buckets. I will talk a little bit more about that later, but basically can read and write your data in the shared allocation. So basically, this is data for the project, but needs to be used with care. And in this case, the individual allocation, nobody else can see your data from here. There are ways of sharing the data to other users. Then you allow other users to see your data here. And in the case of the projects, there are the same ways to share the data with users from other projects. But initially, from the users from the same projects, data is shared by default and cannot be, and that sharing default cannot be changed. Acacia is replacing what previously was intended for the group file system. So Acacia is replacing it. There is no group file system anymore. This object storage has its own authorization access, so you need to get credentials or access keys to access Acacia that are separate from your access from the to the clusters at Pawsey. as I said, the interaction is through a client which is S3 compatible. I already mentioned a little bit about this, but once data is stored in Acacia, the design is that it is to be immutable. So you are not going to be changing your data or working with your data directly in Acacia. So for working with your data, you should first stage it into the Scratch file system of the supercomputer and then work from there. Obviously, this is for many users not a desirable step to all the time be staging your data into Scratch for using it. So there are technologies trying to overcome this, but not ready yet. And at this initial stage of Setonix, this is the way we are recommending to work with, and basically the only way to work with it. Okay, so again, Acacia is not a file system, it's an object storage. So these are the two key concepts of the object store. First, an object. So the ideal translation of an object or very first analogy of an object is basically what in a file system we consider files. But the thing is that files are not just stored as they are attached with an additional data, which is called metadata. And this metadata is information that basically describes the object. So you can work on that metadata and add more description about what that file, that initial file means and contains. So that's the way you keep information and file together into an object. For basic usage of the object store, usually you don't mess with the metadata and you basically copy files into the object store. It is converted into an object which has your file and some metadata created by default. But those objects are not stored in directories as in a usual file system. Objects are stored in buckets. So bucket is the structure that stores the objects. As mentioned here, buckets and directories have similar purposes, but they are not the same. So again, maybe I will say this many times during the module, but this is not a file system, this is an object storage. So you need to be aware of that. So now you are storing things, well, objects in buckets, which are not the same as directories. So for example, one difference is that you cannot create a bucket inside another bucket. So the concept of sub-buckets is not something that can be used. It cannot exist. So that concept of subdirectories is not translatable, transferable into an object storage. So everything is stored in a bucket. So there are no directory trees. Basically, the storage is sort of flat inside the bucket. But you can still organize things inside the buckets with naming your objects. That's what we call prefixes. So basically, the name of the object is extended in a prefix, and that prefix can give you some organization in the bucket. So if, for example, your object is named case 1, and you have case 1, and then you have another case 1 that has a different, that relates to a different data, you can, you can have two buckets, or inside the same bucket, you can rename the object as my my thesis project, then case 1. So that's the whole name. So the prefix is my thesis project, and then case 1 is the final, if I can say, name of the object. So that in that way you are organizing your objects inside the buckets. That should be clear later in the following slides, but that's the idea. Use prefixes to organize your data. And there is no limit in the number of objects that a bucket can contain, but for those that are dealing with a large amount of data, you need to be aware that the performance of writing more data into a bucket or retrieving data from a bucket can be impacted by the number of objects in the bucket. So we are recommending to not use more than 100,000 objects per bucket. Again, more details in the Acacia user guide. Yeah, this went frozen. Okay. So more about Acacia. Acacia is one of the benefits of the new system is that Acacia is connected to all the systems at Pawsey. So you will have Acacia is visible from, for example, Nimbus, the cloud system, and from the visualization clusters from Setonix. And also, they are not here, but also at this point from the old clusters. And if we can say that is also visible from any computer that has an internet connection. And all the access into Acacia is with the same kind of tool. So it is uniform with the S3 protocol, same commands. You can access Acacia from anywhere. So that provides an easier integration of hybrid workflows. For example, those workflows that need supercomputing, cloud, and visualization along the way. It is beneficial to have access to Acacia and to the same data with a uniform protocol. Yeah, and I said, from your institution home, you can retrieve your data using the same commands. So these tables just summarize the same concepts that I already said about Acacia. So I will not go through them, just probably for you, if you come back into the presentation, it will be easier to have these tables and understand some difference between the existing file systems and the new Acacia object storage and the benefits of Acacia. The only thing that I haven't mentioned in the previous slides is this point about policies. So in the previous file systems, the way the files are shared is through group permissions. So these Linux permissions are what allow other users to be able to read, write, or execute your files. In the case of the object storage, there are not those permissions anymore. And the way is to share them is through policies. We are not going to go on detail about this in this module, but you can check in the Acacia user guide on how to share your data from your individual user storage to other users, or from your project storage to users in other projects. Okay. So next section is how to migrate your data from group and into Acacia or the other new file systems. So in other modules, you have seen this slide previously. So I will only focus in this top right image, which is if you have data in any of these file systems in group, Pawsey, even on Scratch or in Astro, that data needs to be moved into Acacia for the new system. Any other data that is in group that corresponds to other places should be moved to those other places. For example, if you have software that is not to be migrating to Acacia, but into this new software file system, if you have data that you are currently working with, probably you may want to migrate it directly into the new Scratch, etc. So for the case of group, here's a simple diagram to decide what to do with your data that you have in group. So working data goes to Scratch, software goes to software. Any configuration files, better to put them on the new home. And now here, if you have data that belongs to the project and the rest of the users in the project needs to have access to it, you put it in the project allocation. We are, as you saw, the project allocation is much more larger than the individual allocation. So we are assuming that users will have the need to put more data into the project allocation, that shared allocation, that in the individual allocation. But if you need that data to be only accessible to you and no one else, you need to put it in the user allocation. Okay, I need to make a pause to have some tea. So talking a little bit more about group. So group is the principal investigators of the projects have or should receive very, very soon a report of the usage in group. And these reports are basically just to be aware of how much data the project has currently in the, in the old group file system, and what kind of data you have. Like, for example, this image comes from that report and is describing for the different users within the project which percentage per user has different sizes of files. So for example, for this first user, around 20% of their own files are over one. Well, it's difficult to distinguish here, but let's say over 1 terabyte. No, should be over 32 bytes, because this is the sequential scale. It goes from green to higher. So yeah, it should be 32 terabytes. It's around 20%, and around another 25%, the files are of 1 kilobyte size. So not very big size of files for that user, and that for all the users in the project. So that can give an idea of what kind of operations you will need to do to basically migrate your data into Acacia. And also, because you don't need to migrate everything you have in in group, so it is a good time to check what really needs to be migrated and what can be cleaned up. So it's a good opportunity of doing some housekeeping in your data and basically start new, like basically start new and clean into Acacia. This is another image that comes in that report. Again, showing sizes of the files, but also the amount of files that each of the users in a project has. So yeah, it's important to check that report to have an idea of how much effort you will need to perform to migrate your data from group into Acacia. So two main important ideas here is that you may be tempted to move directories as they are into Acacia, but basically you need to consider that Acacia is more like an object store. Well, it is an object storage, but it's more a place to store your data. So it is probably more, I would say, more organized and better to store your data, pack your data first into a tar file and then move it into Acacia. So you have like two options. You can store every single file as an individual object in Acacia, or you can pack your information first into a tar file and then move it into Acacia. So those are the two main ways of storing data in Acacia. So some recommendations, check your report and check what you have in group. Define which part of your data needs to be packed and then store as tar files. It is important to know that you don't have to pack everything in a directory as a single tar file. You can make partial packings, if we can say, several tar files, packing different pieces of your information currently in group. You can also define which data or which directories will be mirrored or synchronized into Acacia as they are. So they will appear as every single file will appear as an individual object in Acacia. But yeah, as I mentioned previously, large directories are really not very good candidates to be mirrored into Acacia. It's better to think about tarring them before moving. Also, it is important to basically start small and basically sort of train yourself a little bit in the use of Acacia with the moving and with testing your workflows before doing the final migration of your data. And we are here to help, and we have made a strong effort in our documentation to provide you with most of the information you need, but you can still obviously ask Pawsey staff through tickets to help you with the migration process. Okay, so now some examples on how to use these S3 clients. So the first step is to get your access keys into Acacia. So that is done through the portal, the Pawsey portal, which with this address. So once you are there, you choose Acacia, and then you ask for your access keys. You need to choose if you want your access keys for the project storage or for your individual storage. Those access keys are different, so it is very important that you will to know that you will have 2 pairs of access keys. And for each of the storages, you can generate more than 1 pair. So the access keys come in pairs, basically sort of an ID key and then a secret key, sort of like a username and a password. So they, those pairs, you can generate them many times. You can have a 5 usable pair of keys at the same time, but you can basically, if you want to have another one, you can delete the keys that are currently in use and generate new ones. So the very first time you will need to have 0 use keys and you need to create a new one. Again, as I said, you select which storage you are going to generate those keys. Then after clicking create bucket, create new key, create new key, then the keys are going to be generated. So in this case, you will have an access ID key and a secret key. So these keys need to be copied into a safe place in your own notes. The idea is that this safe place should be a file or a notebook or whatever that no one else have access to it. You cannot share them. That's part of the policies in Pawsey. You cannot share these keys, so it's only for your own use, even with your colleagues in the same project. And once you close those keys are not visible to you anymore, so you need to save them before closing this window. Also very important is that there are examples on how to use these keys to configure the access when using the minio client or when using the rclone client or when using the AWS client. I'm not showing those here, but if you click in any of these points, you will see some instructions on how to configure those keys for the different clients. So this also important to note that each of the clients needs to be configured separately. So you use the same IDs and the same secret key to access your storage in Acacia for the different clients, but those clients need to be configured separately. So it's also a good idea to take note on how to configure those clients, depending on which one you are planning to use. Okay, so in that is indicated in instructions I told you when you click that specific point in the pop-up window of the access keys. But there you will see that the way of accessing Acacia, what is called the endpoint of Acacia is this https://projects.pawsey.org.au. This is for both, for your storage, your project storage, and the individual user storage. This is the DNS name, if we can say, for accessing Acacia. Again, in terms of an object storage, this is called the endpoint. So which client to use? We initially decided to support the MC client, the minio client, basically because of its ease of use. So it's really still, in my opinion, much more easier to use. But there are pros and cons for each of the clients we are currently testing and using at Pawsey. So, but I can say that we stick into these 3 clients. We have not moved out of these 3. So there is some expertise in all of them, but the main official supported client at this point is the minio client. And it is a good starting point for those that do not have any knowledge of how to use an S3 storage. For those that already have knowledge and already use, for example, the AWS S3, they may feel more comfortable using directly the AWS client, or rclone is also a very popular tool for interacting with object storages. We are also recommending to use rclone in batch and Slurm batch scripts because it has a very low verbosity, while MC gives you a lot of output when you are using it in scripts. Okay. These 3 clients are accessible in all our clusters. Only thing you need to do is load their respective modules and follow the configuration instructions to set up your access keys and the endpoints. Because initially, when you load the module, the tool is available, but will not know where to look for your data or where to put your data. So you need to configure it to have access to the different storages in Acacia. Oh yes, and the same clients, these 3 and many others, you can install it in them in your own computer or your institutional computer, and you will be using exactly the same commands from there to access Acacia, but you need to install them there. So basically, the configuration is for all the clients is stored in files, in configuration files. So in the case of the MC client, this is the path, and this is the file where the configuration is stored. So basically, it will store the endpoint and the access keys there. For rclone, this is the files, and for the AWS client, it uses 2 files. But again, endpoint and access keys are going to be stored there. So you need to be sure that none of these files are visible to anyone else but you. These files, I'm talking that these files reside in the host. So in this case, in your home directory in the Pawsey clusters, or in your home directory in your own computer. So just be aware that the access keys are there. And you need to keep those files safe. Okay, so this is an example of how to configure the MC client. So this is the command. So basically here we are configuring, rather than editing the configuration file, we are using a command to set up the access to Acacia. So basically is for any command for the minio client, you need to type first MC and then a command of the client. In this case, the command is alias set. We are going to set what is called in MC an alias name. So you choose what alias name you want to do for your access into Acacia. This name is arbitrary. Then the endpoint that we talked about it a few slides ago. Then the access ID key and the secret key that you got from the Pawsey portal. About the alias name, what we are recommending is to use an alias name that cause no confusion with your local directories in your own file system, because problem is that the MC client does not only interact with the object storage, but can also interact with your own local file system. And when there is some ambiguity, some weird things can happen. Basically, you can start writing into your own file system or things like that. So basically, we are recommending to use a name that clearly says that this is an alias name for Acacia. We are recommending to use the word Acacia, then dash, and then something else for your alias name, but that is your own choice at the end. And here is a screen with the example following this process. So first, we create the directory.mc if it's not there. This is important. We are setting history off. So this command turns off the recording of the history of the commands temporarily, because we are going to turn it on later. But we are turning it off basically to execute this command, because this command will have your access ID and your secret key in the command line. So if you don't turn off the history, then those access keys will reside in the history. If anyone has access to your history, will see your access keys. So basically, turn it off, execute the configuration command, and turn it on again. And basically what I'm doing here is checking that the configuration file exists, but also checking that I am the only one that has read or write access to that file. No one else can check it, not even in my group or anyone, just me. If the permissions to the file are different to this, then you need to change it and should be only read and write for yourself. Another example of configuring, in this case for rclone. And in this case, we are not following sort of the official way of rclone for configuring the client. In this case, we are editing directly the configuration file. So this is this. Basically, this is a copy and paste of the instructions that come from the Pawsey portal when you get your access keys. So the first thing is to create the configuration file if it's not there. The directory for the configuration file if it's not there. Then again, setting off the history. And this line is sort of a tricky command, but basically what it is doing is adding these lines into the rclone configuration file. So basically, we are going to add in brackets some name, which is basically sort of the same as the alias name, although for rclone it's called profile name, but it's exactly the same concept. So we're going to call this profile name Acacia, and then we are suggesting to use your project. So basically the idea is that this this configuration is for your access to the project storage. So Acacia dash and the name of your project. And these lines, which are basically the type of storage, the provider, the endpoint, we talk about that, access key, secret key, and then this end of file line. And then set history on again. So once you have done this, you can check that the profile name exists with this command, and it is basically saying that that profile name exists. Again, it is important that to understand that these are two separate configurations, and the recommendation is to use exactly the same names. But it is up to you. If you finish using 2 or more clients, I find it handy to have the same profile names for all the clients, but again, it is up to you. That's the thing. So now, yep. First step when using the clients is to check that everything is working. So the very first step is I'm going to show the functionality check only with the MC client, but you can do similar steps with the other clients. So in the case of the minio client is MC alias. Now it's not set, but list and your alias name. And then it will respond with the correct information if that alias name exists. Now you can check if you can create a bucket. In this case, MC MB is make bucket, create a bucket. You write the alias, then slash, and then the name of the bucket. And it responds the bucket has been created properly. Then you can list your alias name, and you can see that that bucket has been created. And then, because this was a test, you do MC remove bucket, alias name, slash, the name of the bucket, you remove the bucket. So basically, it is what we are proposing to do the functionality check, some check towards the configuration file being recognized properly, and some check of functionality, basically create a test bucket and remove it. Now, it is important, and you can check more about this in the Acacia user guide. It's important to notice that bucket names cannot be totally arbitrary. There is some kind of an awkward restriction about object names, which is that buckets in the whole Acacia need to be have a distinct name, a different name. So that means that me, Alexis, if I create a bucket called Alexis, and then there is another user that likes the name Alexis or is named Alexis and wants to create a bucket also called Alexis, the first one wins and the second one will receive a message that that bucket already exists. Even if me, Alexis, I have my individual storage and the other user has their individual storage. And totally, we don't know each other. We don't work in the same project. Still, buckets need to have a unique name. So to overcome that problem, we are suggesting the following. You can add in front of the bucket name, the name of your project. So that reduces the chances of having a same naming. So for example, here, I'm doing a MCLS, which is listing what I have in this alias. So in this case, I'm not using the Acacia project name. I'm using my own user storage, which I created an alias as Acacia Mine. And if I list what is there, at this point in time, there was nothing. No buckets there. So then I say, okay, I will create a bucket, Acacia Mine thesis, and then I get an error that that bucket already exists, because someone somewhere already created a bucket thesis. So what we are recommending is to prepend the name of your project. So that's why these letters, if you can see, are in cursive, because you should change this to your own project name. Then you can have this additional distinction within your own project, for example, your initials. But that is, again, it is all your decision, but I guess this best practice is the best way to go to avoid problems. Your project name, then some initials related to you, and then the name you really wanted to put into that bucket. We don't recommend to use as the identifier, the unique identifier, your username, because those bucket names are visible to other users. And if you expose your username, then that can be a security threat, and people could try to access Pawsey systems using your username. So basically, no usernames, some initials maybe, and the name you want to use. And in this case, the bucket was created successfully, and I can list it, etc. The other thing to mention about name restrictions in buckets is that they cannot have capital letters. This is important, I think very important. I hit this wall many times when I started using Acacia. I hit this other wall many times, which is the underscores. So I'm very used to use capital letters and underscores in the naming of, for example, directories. You cannot use underscores. You can use these normal dashes, but not underscores. So these are the two main restrictions, I think. And this is this has to do with Ceph S3 principles and compatibility of the system. These other, I guess, are sort of normal. You cannot have spaces in your naming, and you cannot have some special characters. So basically, in this example, trying to create a name with a capital letter or a space or an underscore will be rejected. Cool. Something that I think is very important, and it's a warning that you need to be aware. I also already mentioned a little bit about it. So all the clients can interact with your local file system. So they are prepared to deal with different kinds of technologies, object storages and file systems, and many others. So if the command is suggesting to interact with the file system, it will interact with it. So for example, this is just an example that something that happens with MC. So MC make a bucket will be understood sort of a mkdir-p as a Linux command of creating a directory if the MCMB is not dealing with something in an object store. So let's go to the example. I think that's more clear. For example, I'm doing this command to see how many directories I have in my current directory, and basically I don't have any but my current directory. So if I do MC make a bucket and I mistype, instead of Acacia mine, I mistype some letters by mistake. The rest is the name of the bucket I want to create. Then the command tells me bucket created successfully. I guess it should, because it is really not interacting with Acacia because this alias doesn't exist. It should come back and say a directory was created or something, but it responds that it created a bucket. So you may think that you created the right bucket that you wanted to create, but it is not. And then you start copying things into there, and the only thing that we'll be doing is to copy things into a directory in your own host file system. So with this mistake not seen and with this message of successful creation, we can try to see which directories we have now in our local directory. And as you can see, what the command did was to create the Acacia Pine directory and the project name ABC test subdirectory underneath. So you need to be aware that always type correctly the name and be aware of this kind of problems. As I said, all the clients have similar problems. So to avoid this problem, you can use the auto-completion for the naming. So for example, you start writing a K and then tab. It will recognize your alias name and type the correct Acacia mine instead of this wrong Acacia pine. You can use variables. That is useful more than in an interactive session, probably more in scripts, but basically once you define this Acacia mine, the correct name into a variable, obviously assuming that this is all correct, then you can use this variable as the alias instead of typing again the alias every time. And if, for example, you mistype the name of the variable, then if that variable doesn't exist, then you will be, well, MC will be trying to create a directory in the root of the file system. And in the case of Pawsey file systems, that will give you an error. Probably not on your personal computer, but will give an error in Pawsey file system. So this is sort of a safe way of avoiding that kind of problems. And also, well, it is a very good idea to check that nothing is being created in your local file system. So this is important to check. Okay, so finally, we are moving into real transferring data into Acacia. So we are going to deal in this module with three use cases. First is just copy a small amount of files, basically sort of testing or first interaction with Acacia. The other case is to synchronize or mirror a full directory. And the other case is to collect multiple files into a single tar file, pack your files into a single tar, and then transfer it into Acacia. Again, for the synchronization or mirroring of a full directory, you need to be aware that if that directory contains many files, then that can be a problem. Again, our recommendation is a top of 100,000, but this is not a configuration limit. It is just a recommendation. Okay, yeah. So when you want to have individual objects instead of a full pack tar file in Acacia, so when you want to have individual objects is when in your workflow, you will not need a whole bunch of files, but just a selected number of files to be staged back into the Scratch file system. So when the amount of files is small and selective, different for different jobs, etc., you may want to have individual objects in your storage. But when there is a pack of files that you will always need to move them together, it is better to have them packed and tarred in Acacia to perform all the data management. Okay, so an example of copying files into Acacia. So here I'm using, again, the MC client, and the command is cp to copy. So basically, well, this is the syntax. MC, cp, these options, we recommend them to use the quiet option and to use the --md5 option. Basically, quiet reduce the verbosity, but this --md5, what it's doing is to check the hash of the file after being copied into Acacia, and to then with that hash checking, it can check if the file and the copy file are exactly the same, basically checking for consistency of the original and the final file in Acacia to be exactly the same files. I think in the new versions of MC, this check is done by default, but to be sure, we added the option here and recommend to use it all the time. Okay, so basically here is the example. This first example is to copy the file Quokka into some alias accessed already configured with the access keys and the endpoint. Then with MC, we use a slash and then the name of the bucket, and then slash, and you can use what I said, well, now so many slides before about the prefixes. So you can define a prefix under the bucket, and then finally the name of the object here. So basically, this is copying this Quokka file into the bucket project name ABC down under, and on using the prefix fauna and the final name Quokka. So here in the syntax, you see alias name, bucket name, prefix. This prefix can be can have many slashes, and then the final object name. This can give you sort of an idea of subdirectories inside the bucket. It is sort of a trick, but it is good to be aware that it is not really sub-buckets. It is not really subdirectories. It is just sort of part of the name of the object, but can be used to organize your data, and in many practical ways can be think of subdirectories, but just to understand that they are not subdirectories, they are just prefixes. It is important to have the knowledge about that. Okay, so if you want to copy all the files starting with K, then you execute the same command. Here use a wildcard to define several objects starting with K. And again, you say the alias, the bucket, the prefix, and then all the K files are copied into there. And then you can list with the alias, the name of the bucket, and the prefix, you can list what is inside or below that bucket and prefix indicated in the ls command of MC. Okay, so this is for copying a small amount of objects or files. For copying a full directory, what we are recommending is to use, in this case, the rclone client. MC has its own command. So it is MC mirror. You can check that in the documentation. But basically what we have seen is that when using these kind of commands with a large amount of files that will take some time to be copied, if there is some kind of failure, rclone is better equipped. I'm sorry for that. Rclone is better equipped to recover from failure than MC, especially in these large transferring commands. So we recommend to use rclone, but basically the idea is the same for both rclone sync or MC mirror. In the case of rclone, we are recommending, so we are assuming, obviously in these examples, we have just a small amount of files, but we are assuming that you may be doing this command for a directory with a large number of files. So we are recommending to use 12 transfer threads for the rclone command. We have seen very good performance using that. So this is the syntax for the number of threads during the transfer. And this option is similar to the --MD5 option in MC, which is checking the MDF5 hash of the objects after transfers. So basically, to check that the files have been transferred properly and correctly, and we have the same files in the original host file system and later in Acacia. So the syntax is rclone sync the options, then the local directory, and here the profile name, which I said is the same as the alias name for MC. Important is that now instead of slash, we are using the colon, then the bucket name and prefixes. And so here's the example. We are going to synchronize or basically copy the full directory Flora into Acacia mine, colon. So this is the profile name, colon, this bucket, project name ABC down under, and then the prefix where I want the content to be copied. In this case, the same prefix, well, I'm using a prefix with the same name of the original directory. So after transfer is done, you can use this MC to list, or you can use the listing commands of rclone. In this case, we use the listing command lsl to list objects in my profile name, well, Acacia mine, the bucket, and the prefix. So this lists the objects that are below this prefix in the bucket indicated. So as you can see, it shows different still part of the prefix and then the name of the object. There is another command for listing, in this case, directories, which we know there are no directories in the object storage, but we use LSD in the prefix Flora, and there you can see all these prefixes that are playing the role of subdirectories inside the Flora prefix. So basically what I was trying to show here is that after the rclone synchronization of this directory, local directory Flora, that move the contents of Flora with its own subdirectories that are not shown here, but we can see that it had the subdirectories inside with the names of the states, well, the initials of the states, and then some information for each state. Everything was copied with that structure, converting the subdirectories into part of the prefix name of the objects. That's it. Now the next case is to pack first and then transfer. So basically, there are many commands to pack information, but the most, I think, yeah, it should be the most common command is the tar command. So basically, we are not going to go deep into the tar command here, but basically you can use the tar command with all its capabilities to create your package of files. In this case, this is a basic syntax for tar. Tar, this is create, how create, then I forgot the word, but compress, show verbosity messages, and then the name of the file that you want to create. So you want to create a file with a specific name, and then after that you put whatever you want to tar into this new tar file. So here is the example. We have originally in our host directory 3 case directories, and basically the example is tarring into case0.tar.gz, the case 0 directory, the same for the other 2 directories. Once you have your 3 tar files, in this case we can list them here. We have the case 0, case 1, and case 2 directory tar files ready. We can copy those files. Again, you can use any client. In this case, we are using MC again. MC copy in a quiet mode, checking for the hashes. We are copying everything that is tarred, and we are copying those into this alias, again, into my own user storage, into this bucket, which I'm following the best practices using the project name, some initial, and then a name, distinctive name. In this case, I'm going to use these bucket tar cases to store all the stars. I'm also using a prefix called 2022, and down there, all the tars are going to be copied. So case 2 is now in Acacia Mine, the bucket, the prefix, and store as a tar file in Acacia. So these two, now in this slide, I'm asking the question, have files been transferred correctly? So in theory, yes. So they should have, because we have these two options in the commands. If there is some error in the checking. So these options guarantee that the files are being checked after being copied. So you will not receive the prompt again, or you will not finish that command without an error message if there is anything that is not identical in the original and in the copy in Acacia. So this is guaranteeing that you will receive an error message if there is some difference in any of the files that are being copied. So we can consider that that is true, and after not receiving any error message, you can delete your data. But if your data is extremely, how to say, sensitive and you need to double check before deleting the data that you have in your original host directory, because obviously after transferring your things into Acacia, basically you will need to delete your files wherever they are. In the case of transferring data from the old group into Acacia, well, if you don't delete anything in the old group, it will be decommissioned in very soon. So that data will be lost. In the case of transferring data from scratch into Acacia, you transfer it, and if you don't delete it from scratch, it will be deleted anyway after 30 days of non-use. So the thing is that the original data is going to be lost. But what we recommend is to basically do it yourself, remove your data from scratch or from your group after it has been copied to Acacia without receiving any error message from the copy commands. But still, if you want to check if it is exactly the same, you can do you can do the command check of rclone, and this will give you a report. So for example, in this case, we are checking if the directory fauna and whatever it is in the storage of my project and this bucket and this prefix in that bucket is the same. So I'm going to check whatever is under this prefix, compare it to whatever is in this directory in my local host. This option is very useful, which is going to put into a output file. You define this name with whatever name you want, and a report of similar equalities or differences. In this case, everything is the same. If there is any difference, you will see different symbols and some other messages. You can check the rclone help of the check command to see whatever the report means. But basically, after this check, for example, for this example, that everything is the same, then it is time to delete whatever I have in the original directory found. And finally, this is the last slide of commands. If we have only covered some commands of transferring data into Acacia, now we need to transfer data from Acacia into Scratch for probably a supercomputing job. So basically, it's exactly to use the same commands, but in the opposite direction. So you can use the copy command to copy files back into your local path in Scratch. So this should be an example to copy. Well, I'm not explicitly saying that I'm copying into Scratch, so I'm assuming that this command is being executed in the path where I want to copy the files. So I'm saying copy whatever is in this alias, this bucket, this prefix, well, not whatever, this alias, this bucket, this prefix, this file, copy it here in my current directory. So I'm assuming I'm already in the right directory in Scratch, and then that file is being copied. And after being copied, because this is a tar file, I need to extract the data that has been packed into the tar file. I need to use another command of tar to extracting. That's this X to extract whatever was or whatever is in that file. And now all these files are being extracted into my local directory, and I can use them for my supercomputing job. Or I can use rclone sync, doing exactly the same options, checksum and 12 transfers threads to do a full copy of whatever is in my own object storage under this bucket, under this prefix, to copy it into the fauna directory in my local host. And then I can ls whatever was there and has been copied. And in this case, only these 5 files were copied. It's just an example. And then use it for your supercomputing job. So basically, this is just to remind you that basically just the opposite commands need to be used for transferring files from Acacia into Scratch or into a local file system. Cool, almost done. Now, probably you don't want to do all this manually all the time. And we want to automate things. So the way to automating the processes is to use Slurm batch scripts. So the recommendation is to use different batch scripts that can be changed together into different steps if needed, but can also be used separately as a single step or task that needs to be done at a certain point in time. So these are 3 clear steps. For example, staging, which is copy things from Acacia and into Scratch. Then there is a job script for anything we have to do with the supercomputing and all the calculations, etc. The normal use of the supercomputing and job submission through a Slurm batch script. That is very common. And also a Slurm batch script to store things into Acacia. So in this case, in this example, we are going to chain these 3 steps: staging something from Acacia, executing a supercomputing job, and then the results, storing them into Acacia. As I said, these 3 steps can be done in a separate fashion, each of them. And some examples of for each of these scripts is already in the Acacia user guide. I will show here a reduced version of those scripts. So for example, for staging data from Acacia, you have a job script similar to this. In this case, what is important to note is that the nodes in the computer that needs to be dealing with this transfer of data are not the compute nodes. They need to be, well, basically, we recommend to use the copy nodes, the copy partition, which are the data mover, the partition that deals with the data mover nodes. So you send this job to the copy partition. Also note that in previous systems, the partition for the data mover nodes was copy Q or copy Q here with a Q. Now we dropped that Q from the names. So in Setonix, it is just copy. the copy partition. And then define how many tasks are going to be executed and how many CPUs per tasks. In this case, how many threads are going to be assigned to that command. So in this case, we are recommending to use 2 threads per task for the MC commands. And in the case of the rclone, for example, if you are doing that synchronization examples that I mentioned in the previous slides, then you will need to ask for more than in the recommendation. I'm saying to use 12 copy threads. So in this case, you should use 12 CPUs per tasks for a job that is using rclone. In this case, the example is with MC. So basically, the first thing is to load the module of minio. We are assuming that minio has already been configured and you know the alias name, etc. So basically, we are defining which file to copy. We are defining the full path in Acacia with the alias name, the bucket name, and the prefix path, and defining the working directory in Scratch with the right path. And then basically use the MC command, MC copy, to copy from what we assign over there in the full path in Acacia, and then the name of the file. So all these is identified as the object we are going to be copying. And then all this is identified as the path where the object is going to be copied. And important when using MC in a script, it is important to redirect the output to dev no. So this helps to reduce the size of the output for the job, because MC is very verbose. So basically, it is important to redirect the output to dev null when using MC in a script. And after copy the tar file that we are intending to use, then you need to untar it. So basically tar extract, and this is where the new tar file exists. And in this case, as part of the tar command, I'm saying where the files that are in that tar file are going to be written with this -c. So basically, this is an example of copying from Acacia and untarring a job submission to the copy queue, to the copy partition. Then you can have any kind of script for your job. In this case, I'm calling this example the super execution in Setonix, loading the tool you are going to use, change into your working directory, and srun the tool that you need to use. In theory, that tool will be using the data that you already transferred in the first stage. And then this is the batch script for assuming that the results have already been generated. So again, loading the minio client. Sorry for that. Loading the minio client, and basically it's the opposite direction of the commands. Now we have a working directory. We need to define which files to tar, define the name of the new tar file. and define the place where we are going to copy the tar file into Acacia, alias name, bucket name, and prefix path. Once you have all that defined, you execute first the tar command, and then you execute the copy command of that new tar name into the full path in Acacia that you already defined. And again, we are redirecting the output to dev null to avoid excessive verbose messages in the output file. So the complete examples in the documentation fill in these gaps of checking that what we are using, the variables we are using here are correct, and we have correct access into Acacia, etc. So there is a bit of checking to avoid errors. Some you can add additional checking for the tar command to see if it has basically packed what you wanted to be packed, etc. And you can do some extra checks to check if the transfer went correct or not. Basically, as I said, once you put this, if you don't receive any error messages, that's fine. So in this case, you can have some checks trying to catch those error messages if you need to do that. Okay, so as I said, you can execute those jobs separately and manually, one after the other, once each of them has been completed. But you can chain them and submit them all at the same time. So basically, for doing that, you need to use, when you submit them, you need to use the dependency option of Slurm. So with this dependency, you can, in this case, for example, we are using -- dependency after OK, colon, and the job ID of the previously submitted job. So basically, this second job will only execute if the first job is executed with a successful end value. And the third job will also only execute if the second job will have an exit value of success. So to catch these job IDs, we are doing all these, if I can say, weird kind of Linux syntax. But here is here's the main command, sbatch. We are using this option parsable, which gives you a different message, output message of the command than usual. Why we are using this parsable? Because we need to guarantee that the output message will always have the same structure, because the second part of the syntax that we have here, which is this pipelining into the cut command, basically is grabbing the first field of the output. And that first field of the output is the job ID. So that's why we are using the parsable, because with parsable, we know that in the output, the job ID is the first part of the output. So that job ID is saved into stage job ID, because stage is the first script that we are executing. Then we use that job ID to be used in the -- dependency after OK. So this second step, the super execution, will only be executed if the stage job ID finishes with a correct exit. And the same for the store into Acacia. We are saving the super job ID, and only if that super job ID is finished with successful exit, it will be executed. And the final command that I'm using in this script that I'm calling it the master workflow is an SQ command, just to check if the jobs have been submitted as I wished. So this is not an Slurm batch script. This is just a simple batch script of Linux that can be executed as this. So this script can be executed just as with its name, master workflow, and that will execute these commands one after the other. And the final command is this SQ that will output what I'm asking to output, which is the job ID, on which partition it has been submitted, the name of the job, the status, etc. So for example, the first one, which was the staging script, right now is not being executed because it has not entered the copy partition yet because of priority, but it has no dependencies. But after this one, we have the super execution that has been submitted to the work partition. And this one has a dependency on the 4785, which is the previous one. And that dependency has not been fulfilled yet, so it is waiting. And the same for the other job. The other job will wait 87 will wait for 86, 86 will wait for 85, and 85 will wait for the partition to execute the job. That's what is being shown here. Okay, this is also explained in the documentation and the example of the workflow. Okay, so this is the end. There is a lot of additional information in the migration user guide of Setonix, Setonix user guide, all our documentation, and in the Acacia user guide, and several modules for training, help, the help desk, and via help@pawsey.org.au. Okay, thank you very much, guys.